Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about asynchronous data transfer. At the end of this video, the student will gain knowledge regarding what is asynchronous data transfer, what are the methods involved in the asynchronous data transfer, and how asynchronous data transfer interface can be functioning. The basic agenda of this video is introduction, asynchronous data transfer, stroke control, handshaking, and modes of transfer. From the functional units of the computer, the basic functional units of the computer are input-output unit, central processing unit. So, input-output unit can provide the interaction to the external world for the computer. So, here to gain the required functionality from the program, the user can give the correct input to the program so that the functionality can be performed and the accepted output from the program will be generated. So, what you see can what you get. So, if the user can give input as garbage, the output can be the garbage value. So, this principle is generally referred as give garbage in, garbage out. So, the peripheral devices can be connected to the computer, need special communication for interfacing with the CPU. So, in computer system, there are special hardware components between CPU and peripherals to control or manage the input-output transfer. So, these components are generally referred as input-output interface because they can provide the communication links between the processor and the peripheral devices. Both the input-output devices that are connected with the computer are generally referred as peripheral devices. They provide the method of transferring information between internal system and the input-output devices. So, the input-output devices can be connected with the CPU or internal system with the bus. The bus is the major used to transfer the data or to shift the data between various components or the functional units of the computer. The bus is generally referred as the system bus. It can consist of three components that are the address bus, the data bus, and the control bus. The address bus is used to carry the memory address to specify the location at which the read or write operation can be performed. The data bus can contain the data that is actually transmitted to the memory or fetched from the memory. The third bus is the control bus. It can generally use it to carry the control signals like read, write, acknowledge signals and interrupt signals can be carried over the control bus. These address bus, data bus and control bus all together can be referred as the system bus. So, these devices, the input-output devices or the peripheral devices can be connected to the internal part of the computer with the help of the interface. So that the transmission can be done, the data transfer can be done between the peripheral devices and internal bus. Why this interface can be required between these peripheral devices and the internal computer? So, here all the input-output devices are generally the electromechanical or electromagnetic devices, but the computer internal parts are the electronic devices. So, they can perform different mode of operation from these electromechanical and electromagnetic devices. So the conversion of signal values may be required between these two to synchronize purpose. The interface can be installed between the peripheral devices and the internal computer. The data transfer rate of peripherals is usually slower than the rate of CPU. So, to synchronize the speed of communication, the IOP can be required between peripheral and the internal computer. And here, various types of data codes and formats can be used by the peripheral devices, which can be different that is used internally in the CPU, the word format of the memory. And the operating modes of peripherals are different from each other and can be controlled and cannot disturb the operations of the CPU, internal CPU. For these reasons, the IOP can be required. So, to synchronize all these accepts between the IO devices and the CPU, the IOP1 interface can be required. How the interface can be communicated with the internal computer. So here the peripheral devices can be connected with the help of the interface to the internal computer or the CPU. So to synchronize the speed mismatch, data format mismatch and the signal mismatch, this interface can be provided. But how this interface can be communicated with these internal parts of the computer is with the help of IO commands. So what are these IO commands? The processor provides the specific function code in the control lines. The CPU places a function code on the control bus of the computer. The interface selected respond to the function code and proceed to execute. So whatever input output device can require the functionality of the CPU can give response to the function code that is placed on the control line by the processor. The function code generally consists of 4 IO commands. The 4 IO commands are control command, status command, output data, input data. These are the 4 commands that are placed as a function code by the CPU on the control line in order to provide service to the corresponding input-output device. So what is this control command? So generally it is issued to activate the peripheral and to inform it what to do. So which input output device can require service from the CPU that can be activated with the help of this control command. And it is instructing the peripheral device what to do. Generally, the read operation and write operation can be performed with this help of this control command. That means from the IO devices, the data can be transmitted to the memory, or the data that is fetched from the memory can be given as output with the help of output devices. So generally the read-write signals can be used for this purpose. The second one is the status command. So here, while performing the input operation, the computer can know where to stop the input operation, how long the user is giving the input. The acknowledgement has to be given with the help of these status registers or status commands. So this status command is used to test various status conditions in the interface and the peripherals. So the input completion has to be acknowledged with the help of this status command. The third functionality is data input command. So generally the peripheral device's basic function is input and output. The data input command is facilitate the input operation. The interface receives an item of data from the peripherals and places it in its buffer register during the input command. The fourth operation is the data output command. It is generally used to facilitate the output operation. The command causes the interface to respond by transferring data from the bus into one of its registers. So with the help of these data input and output command, the read and write operations from the memory can be activated. Either the input-output peripheral devices supplied data can be transmitted to the memory, or the data that is stored in the memory can be fetched and given as the output to the user with the help of output command. So these are the basic IO commands. With these commands, the mm, the CPU can activate the specific interface of the device that requires the service from the CPU. What is asynchronous data transfer? Here, generally in the communication, two devices are minimum involved in the communication. Generally, the devices that are involved in communication can be referred as source and the destination. The device that is initiated the communication and transfer the messages can be generally referred as the source, and the device that receives the information can be referred as the destination. If these devices can be shared the same clock pulse, that communication is referred as synchronous communication. If the devices that are involved in the communication uses different clock pulses, then that type of communication is referred as asynchronous data transfer. Here the control unit can generate these clock signals to facilitate various actions of the functional units. The internal operations of the computer is synchronized by means of common pulse generator that can be the sequence counter used in the control unit of the computer. The clock pulses are applied to all registers within a unit, and all data transfers among internal registers occur simultaneously during occurrences of the clock pulse. So here the various actions of the functional units of the computer can be monitored, controlled and synchronized with the help of the clock pulses that is generated with the help of sequence counter of the control unit. If the registers in the IO interface share the common clock with the CPU registers, then the transfer between the two units is referred to the synchronous. If the common clock signals can be shared by both the CPU as well as the IO registers, then the communication is referred as synchronous communication. So, what is the asynchronous data communication methodology? Asynchronous data transfer between two independent units requires that control signals can be transmitted between the communicated units to indicate the time at which data being transmitted. So, they are using the processor registers, and the IO registers can be used the different clock signals in case of asynchronous data transfer. The asynchronous data transfer can be involved two methods. One is stroke, second one is handshaking. So it is customary to specify the asynchronous transfer between two independent units by means of timing diagram. Why? Because they are sharing that clock signals. So the functionality can has to be illustrated with the help of the Timing diagram. The timing diagram represents the timing relation that must exist between the control signals and data in the buses. How the transfer of data can be taken place that can be illustrated with the help of the timing diagram, and the timing relationship between these communication can be represented pictorially with the help of the timing diagram. So, two methods of asynchronous data transfer can be available. One is stroke control, second method is handshaking. So, the first method is the stroke control. The stroke control method employs a single control line to time each transfer. So, only a single control line can be used in the stroke control method for the transfer of the data. The strobe may be activated either by the source or the destination units. So, here the source unit and destination unit can be involved in the communication. This strobe control can be activated or initiated either by the source unit or by the destination unit. If the strobe control method can be initiated by the source, then that method is generally referred as source initiated strobe. If at all it is the case of destination unit, then that is called destination initiated strobe. So, two methods are involved in the strobe control. One is the source initiated strobe, second one is the destination initiated strobe. Now we have to look into what is source initiated strobe. So here this is the source unit and this is the destination unit. So the data can be carried or transmitted between these two units with the help of the data bus. But when this data can be transmitted means when the strobe has to be activated. So this is the data line and this is the strobe control line. So this timing relationship between the data transfer can be pictorially represented with the timing diagram. So when the source is initiated here from the source to destination, the strobe control line can be initiated. So here this method of data transfer is referred as the source initiated strobe. So whenever the strobe signal can be activated, then the invalid data can be transmitted between the source unit and the destination unit. So that can be represented with the timing diagram. So this method is referred as the source initiated strobe. The second method is the destination initiated strobe. So here the source unit and the destination unit can be involved, and here the destination unit can activate the strobe signal. So here the direction of the strobe signal is from destination unit to the source unit. So this method of data transfer can be referred as destination initiated strobe. So the timing diagram here represented whenever the destination unit initiates the strobe, the valid data can be transmitted from the source to destination. So this type of method is called as destination initiated strobe. So here the source unit responds by placing the request binary information on the data bus. The source unit places the request for the data transfer. The data must be valid and remain on the bus as long as the destination unit to accept it. The falling edge of the strobe pulse can use again to trigger a destination register. So the destination unit then disables the strobe. So why? Because it is a destination initiated strobe. So finally the source removes the data from the data bus after determined time intervals. So in this case, the strobe may be a memory read control from the CPU to a memory unit. The CPU initiates read operation to inform the memory, and the control line carries the read signal. So here to place the selected word into the data bus. So the read operation from the memory is carried out with the help of destination initiated strobe. So this is the asynchronous data transfer strobe control method. In the strobe control method, again two sub methods are there. One is source initiated strobe, second one is destination initiated strobe. The next method is handshaking. The another variety of asynchronous data transfer is handshaking. So the strobe method has the disadvantage that the source unit initiate the transfer has no way of knowing whether the destination has received the data that was placed in the bus. So there is no acknowledgement that data can be received correctly with the destination unit in case of strobe method of transfer. So that is the major drawback of the strobe control method. Similarly, a destination unit that initiates the transfer has no way of knowing whether the source unit is placed data on the bus. So here the acknowledgement of placing the data by the source unit cannot be received by the destination unit in case of the destination initiated strobe control. So to mitigate this disadvantage, the second method can be used, that is the handshaking. The handshaking method solves this problem by introducing a second control signal. So here two control signals can be used in the handshaking. So in the strobe control, only a single control signal can be used. So this second control signal that provides a reply to the unit that initiates the transfer. So this second control line can be generally used as acknowledgement purpose that either the source or destination can receive the data correctly. This method is called the handshaking. In the handshaking also, again two methods are there. One is source initiated handshaking. Second one is destination initiated handshaking. What is source initiated handshaking? So here the source unit and the destination can be employed for the data transfer, and here the data bus can carry the actual data that is involved in the communication, and here apart from the data valued, data accepted two control signals can be used in this type of communication. So here from the timing diagram, the timing relationship of exchange of signals between the two units can be represented, and the source initiated the transfer by placing the data on the bus. So it is a source initiated handshaking. So the source unit can places the data on the data bus and activate the data valid signal. The destination unit activates the data accepted signal after it accepts the data from the bus. If at all the destination is ready to accept the data, then the destination unit places the data acceptance signal over the line. So the source unit then disables its valid data signal, which involves the data on the bus. So after this, the destination unit disables its data acceptance signal and system goes into the initial state. Now the two devices are ready to communicate. So the data has to be transmitted. The source unit does not send the next data item until after the destination unit shows readiness to accept the new data. So here the first data item that is sent by the source can be correctly received by the destination. It can be indicated or acknowledged by placing the next data acceptance signal. So until that time, the source can wait, and if at all it receives the data acceptance from the destination, then only the next data item can be transmitted over the line. So this is the source initiated handshaking. So this is the timing diagram of the source initiated handshaking. So the data bus can carry the actual data that involved in the communication. So here, whenever the data can be placed by the source unit, and it can activate the communication. So if at all it receives the data acceptance signal, then only the valid data can has to be transmitted. And after receiving the data acceptance of the next item by the destination unit, then only it has to send the next item. So here the sequence diagram which will represent the events that are involved between the source and destination during the communication. So this is the source unit. First, the source unit places the data on the bus, enable the data valid signal. Next, ready data from the bus, enable data acceptance. So the destination unit can has to place the data acceptance. Next, disable data valid, invalid data on the bus, so that the transfer can has to be taken place. Disable data accepted, ready to accept the data. So after correctly receiving the data, the destination unit can again put the ready to accept data, so that the source unit can send the next data item for the communication. So this is the source initiated handshaking. The other method of handshaking is destination initiated handshaking. The destination transfer is initiated, so the source unit does not place data on the data bus until it receives a ready data signal from the destination unit. Here, the destination unit has to wait until the source can send the data acceptance signal. That's why this method is referred as destination initiated handshaking. So here the handshaking process is the same that of the source initiated. The sequence of events can be displayed with the help of the sequence diagram. So this is the source and destination unit. So the database carries the actual data for communication. So here as soon as data transfer can has to be activated, so ready for accept signal can has to be sent from the destination unit to the source unit. So here if it all source is ready for acceptance, then only the data transfer can be taken place between the destination unit and the source unit. So here place the data on the bus, enable data valid by the source unit. And next here the ready to accept data, enable ready data can has to be activated as a first step in the destination unit. Why? Because it is a destination initiated handshaking. After looking into the data valid, then only place the data on the data bus, enable the data valid by the source unit. So after this, the acceptance of data bus can has to be done. The data can be transmitted between destination to source. So after this, disable ready for data. So disable data valid, invalid data on the bus, so that whenever the source is placed ready for data, then only the destination can place the next item for the transmitted between the destination to source. So this method is called the destination initiated handshaking. So asynchronous data transfer majorly involves two methods, stroke control and handshaking. In the stroke control also two methods are there. source initiated stroke control, destination initiated stroke control. The second method is handshaking. In the handshaking can use two control lines. Why? Because to acknowledge the data transfer, the second control line can be used by the handshaking. And two methods are involved in the handshaking. One is source initiated handshaking. Second one is destination initiated handshaking. So the another part is asynchronous serial communication. So here in the serial communication, the communication interface in which signals are used may not synchronize with each other using a common clock signal. So here the common clock signal cannot be used. So how can the start and stop of the communication can be recognized? So here the start and stop bits are used to indicate the beginning and ending of the data message. So here the synchronized clock cannot be used here. So to indicate start and stop of the message, two special bits are used. One is start bit, second one is stop bit. So this type of communication utilizes a point-to-point type of interface. So these two devices must also agree upon the baud rate. Asynchronous serial communication can be implemented either in full duplex or in half duplex configuration. So how the message transfer can be taken place in case of asynchronous serial transmission. So here between the correct message, the character bits, to indicate the beginning of the message, the start bit can be placed, and to indicate the end of the message, the stop bit can be placed. Asynchronous communication interface. So how this interface can be used? The interface is initiated by the help of control bit loaded into the control register. How this communication interface can be? This is the block diagram of the interface. So here chip selection lines can be represented. Register selection, RD means read, WR means write operation. And here the control register, status register, receiver register, transmitter register. These four registers can be connected to the timing and control via the internal bus. So here a bus buffer can be used to store the data. So here, whenever used read and write operation, either the data from the memory can be fetched or the data from the IO devices can be transmitted to the memory. That's why here receiver register and transmitter register can be used for these two purposes. Temporarily for storing the data internally, the bus buffer register can be used. And here the control register can specify what to do. That is, either the read or write operation can be performed. That can be represented with the control register. And how long this operation can be performed, that can be represented with the status register, which gives acknowledgement of transmission of data. So this is the block diagram of the interface. The interface is initialized with the help of control bit loaded into the control register. So to initiate the peripheral devices and CPU communication, the CPU must place the control bit in the control register to activate the IO transfer. The transmitter register accepts the data byte from the CPU through data bus, which is then transmitted to shift register for serial transmission. So in case of the data is fetched from the memory, the data can be placed in the bus register. So the serial information is received into another shift register and transmitted to the receiving register with the complete byte of accumulation. So here the chip select input can be used to select the interface by using the address bus. The register select is associated with the read and write controls. These two registers are used for to perform the two operations, read and write operations. Okay. So here this is the chip select line can be used to receive data from the address bus, and these register select can be used to select in order to activate the corresponding read or write operation. And this is the truth table of the interface. Whenever the chip select is 1 and RS is 0, WR signal can be activated. Transmitter register has to be selected for the operation. In case of CS and RS can be 1, WR can be selected, control register can be selected. So here 10 means read operation can be selected, receiver register can be activated, and 11 means RD can be selected and the status register can be activated. So these 4 register, with the help of these 4 register, the IO command has to be received by the interface to which can use it to involve in the actual data transmission. Next is mode of transfer. So here the binary information that is received from an external device is usually stored in the memory unit. Whatever data programs can be generally used to store in the memory. This information is transmitted from CPU to the external devices is originated from the memory unit. The CPU merely processes the information, but the source and target is always the memory unit. Whether you have to dump or transfer data from IO devices to the memory, or from the memory the data can be transmitted to the peripheral devices. So either the source or target can be the memory unit. Data transfer between CPU and IO devices may be done in different modes. Majorly, 3 different modes are available. The modes are programmed IO, second one is interrupt initiated IO, third one is direct memory access. These are the 3 types of data transfers or mode of transfers. What is programmed IO? The programmed IO can be used with the help of software instruction. The input-output operation can be activated and controlled. So, it is due to the result of the IO instruction that is written in the computer program or software. Each data item transfer is initiated by an instruction from the program. Usually, the transfer is from CPU register and memory. This case requires constant monitoring by CPU and the peripheral devices. So, with the software, the IO operation can be controlled and monitored. That type of mode of transfer generally referred as programmed IO. The second method is, and here the example of programmed IO is, if the IO device does not have direct access to the memory unit, then a transfer from IO device to memory requires the execution of several instructions by the CPU, including input instruction. In case of input instruction, the data can be transmitted from the devices to the CPU and store these instruction transmitted data in the memory. In case of output instruction, the data is fetched from the memory and can be transmitted to the peripheral devices. So, in programmed IO, the CPU stays in the program loop until IO unit indicates that it is ready for data transfer. So, infinite loop can be run in order to activate and complete the IO operation that is required by the program. This is a time-consuming process That's why to avoid this disadvantage, the interrupt IO facility can be used. In the interrupt initiated IO, which peripheral device requires service by the CPU, it can raise the interrupt so that the CPU can temporarily halt the current executing program and return to the service of the interrupt service routine, so that the input output operation for the peripheral devices can be completed. So, this method of data transfer is generally referred as interrupt initiated IO. By using interrupt facility, the special command to inform that the interface to issue an interrupt request signal whether data is available from any device. In the meantime, the CPU can proceed for any other program for execution, so that the continuous loop that is caused in the previous case, the programmed IO can be mitigated here in case of interrupt initiated IO. So, upon detection of external interrupt signal, the CPU stops temporarily the task that is being executed and branches to the service program to process the IO transfer. So, in this way, the interrupt initiated IO can minimize the drawback of programmed IO. The third method of data transfer is DMA, Direct Memory Access. The data transfer between fast storage media such as magnetic disk and memory unit is limited by the speed of the CPU. So, to synchronize these speeds, the DMA can be used. Thus, the user can has to allow the peripherals directly communicate with each other using the memory buses, removing the intervention of the CPU. So here the CPU can be the communication or intervention of CPU can be eliminated in case of direct memory access. That's why the name direct memory access. The peripheral devices and memory unit can be involved in the data transfer. This type of data transfer technique is known as direct memory access. So, during DMA, the CPU is idle and it has no control over the memory buses. This mode of transfer is generally referred as DMA. How the data transfer can be carried out with the help of DMA, we'll see in the next videos. So, three types of mode of transfer can be available. One is programmed IO, second one is interrupt initiated IO, third one is DMA. So in this video, I discussed about the asynchronous data transfer. What is asynchronous data transfer? Why it is needed? And what are the methods of asynchronous data transfer? Basically, the strobe control and the handshaking method. And what are the disadvantages of strobe control? How it can be mitigated with the help of handshaking by introducing a special control line, and how the asynchronous interface can be employed, and what are the various mode of transfer like the program IO, interrupt initiated IO, and the DMA. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.